Hi everybody, I thought I'd do something a little bit different today. I'm not aware of there being a lazy list library in Go. Maybe there is one, but I thought I'd just write one quickly, because it shouldn't be that difficult to do. Let's see, let's create something for that. Let's call it lazy list. Go into this and let's create a file. Lazy list.go, and let's start typing. What do we need to do as well? We may want to create a project. I suppose a project, a module. Let's do that. Nope, don't do that. Lazy list, mod init lazy list. Oh, it's annoying with the different keyboard layouts. Okay, package lazy list. So what are we looking for here? What we need to find is a good type for a lazy list. And the easy way to do this, the idea of a lazy list is that you have, rather than having a long list of stuff, so 1, 2, 3, 4, etc. What you do is you have a list containing one and the promise to compute the next element when you get to it. The reason for this is, as you can see in SICP, Structure Interpretation Computer Programs, they have the idea of, let's say you have a list containing the first let's say 1 million numbers from 10,000 to 100,000. So you have some sort of list or some even larger number. And what you want is you want to just find the first 2 primes in this list. And that's quite wasteful, because you'd be generating all these numbers. The only thing you want to do is find the first 2 primes, and you'd be checking to see if they're prime. Let's make it even crazier. Let's map these to, let's filter by prime, and then take 2 or something is what you'd be wanting to do. And of course this is quite takes a lot of computing power, because you have to filter numbers of prime before you take 2. So the basic idea of a lazy list is that you just pull on it here by taking 2, and it gets filtered, and you only actually generate enough numbers and filter enough numbers in order to get 2 primes. Here's the example they had. So the basic idea is you have a type, which I'm going to call lazy list. I know there's a lot of stuttering going on in my type names here. Let's start by saying that this is just a function which will takes nothing, and it returns an integer and another lazy list. That's the definition of this function. You get a number. Once you've got it, you get this function which promises to get you the next number as well. Let's see how we could use this. Let's see how we can implement this. Let's take an int generator. Int generator with a from, to, and a step or something. And it's going to return a lazy list. How is it going to do this? Well, first of all, it needs a condition to break. So if from is greater or equal to 2, we're just going to return nil. Otherwise, we're going to return a function which returns a lazy list. No, it doesn't. Returns an int and a lazy list, because we want to implement a lazy list. And what we're going to do here is we're going to return from, and then an int generator of from plus step to step. This is my way of generating this. What am I doing wrong here? I've got one. Okay, this looks better. And from to nil, we need to return nil. Okay. So let's have a look at what this does. It's not quite that intuitive. you get this from, which is the number you pass to the int generator, and the second time you create an int generator, you pass it from per step as from. If from is bigger than 2, you just return nil, so what comes back will be 2. And the step, you just carry on, just give that to the next call. Okay, let's see if we can test this. So we can see how this will work. Func test int generator. Oh, that's a bug. Why isn't it imported testing? Let's go to the symbol, and it's got to be a go import. An eglot import. No, it was a go import. Import add CCA testing. Be nice. Okay, cool. So let's just make our int generator. IG is equal to int generator from, let's say 2 to, let's say 10 with steps of 3. Make it a little bit larger. 2, 12 steps of 3. So what we'd expect is if we get all the numbers which is going to produce, going to 2, 5, 8, 11. So let's see this. For IG not equal to nil, let's save all the numbers. Result int var e int eig equals ig. That looks good. So we're calling ig and we're getting an integer back, and we're getting, let me show you this while we're doing this. Let me show you how this works. Let's just finish off typing this. Results E. I can't type. Okay. And it's called result, which isn't good. Result should be nicer. Good. Okay. So this will be the interface for how we use it, which you can see here. That's our interface. Type lazy list function, which returns an int and a lazy list. That's what we're doing here. We're calling ig and we're getting our function back. This is the ig. We're getting an I back, which is our int. Okay, cool. So what we want to do is we want to check to see if these are the same list. We're going to slice equals. If not, I can't type today. Results, what we're looking for is 2, 5, 8, 11, t.fatal f, unexpected results, and let's just print them so we can see what's going on. Okay, so now we need to make a function slice equals, takes an S1 and S2, a slice of int, and it returns bool. Okay, so if len S1 is 0 and len S2 is 0, return true. Let's do this recursively. If len S1 is 0 or len S2 equals 0, return false. So one of them's ended before the other one. If S1 0 not equal S2 0, return false. Otherwise return slice equals S1 1, S2 1. Okay. That may well do it. Let's see. Unless go test. It seems to be happy. Let's break it to make sure that something's gone wrong. Okay, so that's not how we've broken it. And it fails. Good. 2, 5, 8, 11 came back. Good. Okay, so that's basically doing the generator. Now let's add a couple of functions to do something. A couple of transformations. Let's start with a filter. And filter takes a, which way around do you want to do this? Let's give it the generator the second argument. So it takes a predicate, which is a func, which takes an int and gives a boolean back, and it takes a lazy list as well. Lazy list, and what it returns is a lazy list. Okay, so if L equals nil, return nil. That's the first thing. If we've reached the end of the lazy list, just return nil. If not, what are we going to do with this filter? Well, let's get everything out of the lazy list which is coming. So we've got an I, and L2 is equal to L, let's call it. And if predicate of I, return I, and then filter of predicate L2. That looks okay. Otherwise, no, not that, which the func which returns that. Okay, that looks better. Yep, what doesn't it like here? Unexpected expression. Oh yes, we're missing that, aren't we? Okay. It's still a bit confused, I can't quite pass it. Else return. Let's just return filter of P and L2, so we'll just continue to the next possibility. Okay, that looks okay. No, I've done that. Okay. Let's see if this works. So IG is equal to, let's make it an F, is equal to filter. If we want to check, let's just take a func int, E int gives the bool back and return E modulus 2 is equal to 0. Let's filter for even numbers, that's an easy thing to do. And let's take an int generator. Let's take the same one as before. Why not? Our results. Now we need to get our results. Int for maybe we should extract this bit of code. Let's extract this bit of code. Get all from a lazy list. It's going to give a list of ints back. Var results int var e int for L nil IL equals L results equals append results E return results. Okay, so that's the basic get all. Actual is equal to get all from F if not slice equals actual, and what are we expecting here? We're expecting 2, 5, 8, 11, but only the even ones. T.fatal F unexpected results. It would be nice to change that to something a little bit nicer. Okay. What am I doing wrong here? Actual. Okay, let's see if this still works or what I've got wrong. It's okay. Cool. One thing we could maybe do now that Go supports generic, so let's make this generic. So we have a t which can be anything here, a type parameter, and it returns a lazy list of t as well. Int generate returns a lazy list of int, always. Filter is a t of any, provided our filter function takes a t and lazy list a t, and it gives back a list of t's. So return func t. This looks okay. What's going on? Oh, int is wrong here. That should be a t. Okay, that looks okay. We've got some problems up here with our slice equals. That's a t, so we need to have here a t, and there's got to be a comparable because we're using equals here. What's the next problem here? Get all is wrong. This looks better, and it's got to say a function which expects a generic function. It needs that. It's not quite happy. Any. Okay. What's going on here? E is int. It shouldn't be an int. It should be a t. And now we seem to have replaced it everywhere it needs to be replaced. Let's see if we broke anything. No, it's okay. Cool. What's the next thing we could do here? Let's add a map. We're going to need 2 type parameters for that. Okay. Okay, and I'm back. So we've got a map function. So let's take our function which takes it's a function of t and r. It takes a t and it returns an r. And let's take our lazy list here, which is a list of t. I'll call this L. And what this returns is a lazy list of R, I suppose. So let's get a bit more space here. Let's move this to the right, to the left, Okay, then we have a little bit more space. So if g equals nil is a simple one, return nil. Else what we return is a func of R and lazy list of R. Return F on. Hang on, we need to get the. Let's get this here. So lm L2 is equal to L. Let's return the F of lm and a map of F and L2. That looks okay. What is it not happy about here? Oh, G is not nil. L. Why do I call it G? Whatever. Okay, so let's add a test for this as well. Test map t testing t. M is equal to map func of. Let's take an int and returning a string. return format that is print f of this font I. Okay, and let's take our int generator as the last time and see what happens. Actual is equal to get all m, and if slice equals, if not slice equals actual, what do we expect to get here? We expect to get a 2, a 5, an 8, and an 11. Then we add t.fatalf unexpected results. It may be good to write something a little bit more sensible there than just unexpected results, but whatever. That needs a closing brace. And that's not an int slice, that's a string slice. Okay, that now looks okay. Let's see if it works. Yes, it works. Right, this is a basic idea. The next thing we'd want to do is a take, which would take an n int and an l lazy list t, and it returns a lazy list of t. You can imagine how this works. You'd change the equals nil or n equals 0, and you can imagine this carrying on like that. Another thing we could do is we could do a func partition in groups of n, l lazy list t, which gives a lazy list back. You can imagine some way of doing this as well. Probably with an probably you'd have a force here. E is equal to 0, E is less than n, E plus plus. And you can imagine going through just getting different what's it unhappy about here? That's incorrect, isn't it? You can imagine it going through the lazy list and just repeating, getting the first element of the list until it's filled up a certain return array, and it'll return the return array, etc. So lots of different things to do here. That's the wrong type signature, isn't it? It's not a lazy list of t, which it returns a lazy list of a list of t. So that would be the correct type signature here. Oh, is that how you do it? List of lists in generics? No, I'm not sure how to do that. Have to look up how to do it how to do that with generic types. Okay, so I hope this is interesting to somebody. I may play around with this library and upload it to GitHub at some stage. Who knows? If not, it's quite an easy thing to write, as you can see. Okay, have a nice day. Bye.